হ্যালো স্টুডেন্টস, ওয়েলকাম টু বেবি স্যার ক্লাসেস। তো দেখো তোমাদের জন্য তো আমি সাকসেসিভ ডেরিভেটিভের খুব ইম্পর্টেন্ট সিরিজ বানাচ্ছি, যে সাকসেসিভ ডেরিভেটিভ আমাদের মেজর, মাইনর, ডিফারেন্স সব স্টুডেন্টস এর জন্য ভেরি ভেরি ইম্পর্টেন্ট। তো দেখো তোমরা আজকের আমি আর একটা সাকসেসিভ ডেরিভেটিভের উপর আমি একটা ইম্পর্টেন্ট পার্ট নিয়ে এসেছি। তো এই পার্টটা দেখার আগে ডেফিনেটলি তোমরা আমার আগের পার্টগুলো দেখে নিও। ডেসক্রিপশন বক্সে তোমার লিংক দেওয়া আছে, কমেন্ট করতে ভুলবে না। তো আর কথা না বাড়িয়ে চলে আসি ডাইরেক্ট আমাদের টপিকে। আজকের আমাদের যে ইম্পর্টেন্ট টপিক সেটা হলো সাকসেসিভ ডেরিভেটিভ অফ y ইজ ইকুয়াল টু e টু দা পাওয়ার ax ইনটু sin bx। আমরা আজকে ক্লাসে ফাইন্ড করব এটা সাকসেসিভ ডেরিভেটিভ, খুব খুব ইম্পর্টেন্ট এটা কিন্তু ফর মেজর স্টুডেন্টস, ফর মাইনর স্টুডেন্টস, ফর ম্যাথমেটিক্স। তো দেখো তাহলে কি করে সেটা করা হবে। তো দেখো ফার্স্টেই আমরা সাকসেসিভ ডেরিভেটিভে কি করি, ফার্স্ট অর্ডার ডেরিভেটিভ। তো দেখো ফার্স্ট অর্ডার ডেরিভেটিভ আমাদের কি হয়, দেখো e টু দা পাওয়ার x কে ডেরিভেটিভ করলে a ইনটু e টু দা পাওয়ার x keeping sin bx fixed, u into v rule ধরে দেখো ডিফারেন্সিয়েশন করা আছে, u into v rule, দেন দেখো e to the power x keeping fixed, ডিফারেন্সিয়েট করো তুমি sin bx কে। what is the derivative of sin bx? this will be b into cos bx। আর এখান থেকে দেখো e to the power x টাকে দেখো কমন নিতে পারি, this will give you a sin bx plus b cos bx। so see that there is my first order successive derivative, my first order derivative। এবার দেখো সাকসেসিভ ডেরিভেটিভের যে মেন পোরশন সেটা কি হয়, প্যাটার্ন। তোমাকে একটা প্যাটার্ন পেতে হবে সাকসেসিভ ডেরিভেটিভ থেকে, সেই প্যাটার্নটা আমাদের ইউজ করতে হবে। তো কি করে সেই প্যাটার্নটা আমরা পাবো, এইবারে স্টেপটা কিন্তু ভেরি ভেরি ইম্পর্টেন্ট। দেখো এবার এই প্যাটার্নটা কি করে পাচ্ছি, এটা করবার জন্য আমাদের যেটা করতে হবে না, এটা আমরা অলওয়েজ কি করব, দেখো এই যে এ দেখতে পাচ্ছ না, এই এটাকে আমরা কোড করি আর cos থিটা, এটা কিন্তু আমরা অলওয়েজ করে থাকি। এই এটাকে আমরা পুট করব হচ্ছে আর cos থিটা, আর এই যে বি দেখতে পাচ্ছ আমরা বি কে রাখো পুট করব হচ্ছে আর sin থিটা। এই দেখো এখানে করা হচ্ছে মাই এ ইজ আর cos থিটা, মাই বি ইজ আর sin থিটা। এটা কেন করা হয়, বিকজ সাকসেসিভ ডেরিভেটিভের টার্গেট কি, প্যাটার্ন। এই প্যাটার্নটা আমাকে যদি পেতে হয় না, টু গেট আ প্যাটার্ন উই অলওয়েজ নিড টু ইউজ দিস, মাই এ উইল বি আর cos থিটা, মাই বি উইল বি আর sin থিটা। দেন what is my y1? Say that my y1 will be e to the power x remain as it is, a এর জায়গাতে পুট করো r cos theta, my sin bx remain as it is, b এর জায়গায় পুট করো, সরি it is r sin theta, এই দেখো r sin theta, b equal to r sin theta, তো b এর জায়গায় পুট করো r sin theta, my cos bx remain as it is। তো দেখো এটা কিন্তু অলওয়েজ করতে হবে আমাদের, এটাকে আর cos থিটা, বিটাকে আর sin থিটা। ওই যে বললাম প্যাটার্ন, ভালো করে ভিডিওগুলো দেখো, সাকসেসিভ ডেরিভেটিভ থেকে তোমার কোনো ডাউট থাকবে না, ঠিক আছে? আর যখনই কোনো না কোনো ডাউট থাকবে ডেফিনেটলি আমায় কমেন্ট বক্সে লিখে দেবে, নেক্সট ক্লাসে আমি তোমার সমস্ত ডাউট ক্লিয়ার করব। ওকে, কারণ আমাদের টার্গেট এখানে ম্যাথটাকে নট অনলি লার্ন করা, আমাদের হচ্ছে ম্যাথটাকে আমরা ভালোভাবে শিখবো। আমরা শুধু লার্ন করব না, আমাদের এখানে ভালো করে শিখতে হবে, কনসেপ্ট বিল্ড করতে হবে, তার জন্যই আমি আছি। তো দেখো তাই যেই আমরা এখান থেকে এরকম ভাবে সাবস্টিটিউট করছি না, মাই a equal to r cos theta, my b equal to r sin theta, after that we can take r common, see that we are taking r common, so we are left with sin bx cos theta plus cos bx sin theta, see that we are left with this, and there is a formula, this is my formula, sin a cos b plus cos a sin b, this is my cos bx, sin a cos b cos a sin b, দেখো লেখা আছে, দেখো এই দেখো sin a cos b cos a sin b, এই দেখো sin a into cos b cos a into sin b। এই ফর্মুলা কি হয়, দেখো sin a cos b cos a sin b, ফর্মুলা তোমার হয়ে যায় sin a plus b। ওকে, ট্রিগোনোমেট্রির উপর একটা আমি ফর্মুলা চার্ট আমার ডেসক্রিপশন বক্সে আমি দিয়ে দেবো, ওই ফর্মুলা চার্টটা ভালো করে দেখে নেবে। ওকে ওকে, সবাই যেটা দেখতে ভুলো না। তো ফর্মুলা চার্টটা খুব ইম্পর্টেন্ট আছে। তো দেখো this is my first order derivative, my first order derivative y1, this become this, এই দেখো see that my y1 this become r into e to the power x sin theta plus bx। using this we shall find a pattern now। okay, how we can find the pattern, see that, so this become my first order derivative, and now the rule of successive derivative, we know we have to differentiate this again, e to the power x into sine bx in this type of form. Okay, e to the power x into sine bx, first differentiate. So my first step is what? Differentiate. After that, put a equal to r cos theta, b equal to r sine theta, so that our first order derivative reduces in this form. So whenever there will be e to the power x into sine bx, see that this a, power of e. What is a? A is basically power of e. This power of e is my r cos theta. And what is b? B is the constant term involved with sine theta. Okay, b is the constant term that involves with sine theta. That b will be taken as r sine theta. It is always true. Okay. So whenever you will find a question like this, e to the power x into sine bx, always proceed like this. So after having this, what is my next target? My next target is to find my second order derivative. So we can do second order derivative similar to this. See that this is my first order derivative. So how we can find second order derivative? My second order derivative, that will be differentiate this again. See that my r is constant term. So differentiate this by using u into v rule. U into v rule. What is u into v rule? At first, differentiate e to the power x. What is the derivative of e to the power x? This will be a into e to the power x. Keeping sine theta fixed. See that, keeping sine theta fixed. See, my sine theta is fixed. After that, what? We can take r common. My r is constant. Then, by u into v rule, keeping e to the power x fixed. Keeping e to the power x fixed, differentiate sine theta. Differentiate sine theta. What is the derivative of sine theta? Derivative of sine theta will be cos theta. And by chain rule differentiation, we need to differentiate this theta. We need to differentiate this theta. What is the derivative of the theta? The derivative of the theta will be derivative of bx, that will be my b. Derivative of bx, that will be my b. So this is my second order derivative. Okay. See that this is written here, r into this plus e to the power x into this. Okay, this is already written here. Then what? Again the same trick. Again we shall apply the same trick. We shall put a equal to r cos theta and b equal to r sine theta. You can do it yourself. It is given here. See that we can take first of all e to the power x common. So after taking e to the power x common, we substitute a as, what is my a? My a is r cos theta. So substitute a as r cos theta, keeping sine theta fixed. Keeping sine theta fixed. Okay. See that. Keeping sine theta fixed. After that, keeping cos theta plus bx fixed. Put b equal to this. B equal to r sine theta. So what we are doing is very, very simple. We are simply substituting a equal to r cos theta. Say that my a is r cos theta, my b is r sine theta, as we have done here. After that, what I'm writing here? What is my y2? Why I'm writing here? Because see that now I shall get a pattern. Now I shall get a pattern. That is why I'm writing here. So see that, first of all, you can take r common. See that you can take this r common. Okay, right? And this r will be multiplied with this r. This r will be multiplied with this r. So that will be my r square. You can take, okay, my e to the power ax will remain as it is. After that, what we are left with? We are left with sine theta plus bx. Sine theta plus bx multiplied with cos theta. Then cos theta plus bx multiplied with sine theta. We are simply taking r common, no? After taking r common, this r will be multiplied with this r. R into r giving you r square. And all the remaining portion remain as it is. All this portion remain as it is. So see that my y2 become what? See that my y2 become r square a to the power x. Again the same formula. Sin A cos B cos A sin B. Sin A cos B cos A sin B. What is the formula? The formula is sin A plus B. See that it is written here. Sin A cos B cos A sin B. Formula is sin A plus B. A plus B giving you theta plus theta as 2 theta. See that theta plus theta as 2 theta plus bx. So see that this become my second order derivative. See, okay? But that is the main part. So this is my second order derivative. This is my first order derivative. See, can you get a pattern? Can you get a pattern from this? Think yourself. Think yourself. Okay, pause the video and think yourself. Can we get a pattern from this? Yes. See that in my first step, power of r is 1. In my second step, power of r is 2. So in my third step, directly we can write here. Directly we can write here. See that in my first step, power of r is 1. Second step, my power of r is 2. So in third step, my power of r will be 3. Negative. See that every time there is e to the power x, it remain unchanged. So write down e to the power x. See that at each step we have e to the power x. So keep e to the power x as it is. Now see that in first step this is sin theta plus bx. In second step it becomes 2 theta plus bx. See that in first step this becomes theta plus bx. In second step it becomes 2 theta plus bx. So in third step this will be 3 theta plus bx. Right? See, you can also write this as r square e to the power x sin 2 theta plus bx. No problem. You can write this. Say that. Bx plus 2 theta means 2 theta plus bx. So in third step, we shall get 3 theta plus bx. So this will continue like this. So this is my first order, this is my second order, this is my third order. So what happens if we continue like this? Say that if we continuing this way, continuing in this way at the nth step, what we shall get? Okay. See. So we shall get what? See that. We continue this pattern. What will be my nth order derivative? See that at the second step, power of r was 2. At the third step, power of r was 3. So at the nth step, my power of r will be n. Then see that in my first step, there will be e to the power x. In second step, again e to the power x. So whatever my step, e to the power x is always there. So e to the power x is always there. Now in first step, there was sin bx plus theta. In second step, there was sin bx plus 2 theta. In third step, there was sin bx plus 3 theta. So at the nth step, this will be sin bx plus n theta, right? Okay, so this is my final answer. My yn, nth order derivative become this. So okay, so if my y is e to the power x multiplied with sin bx, y is e to the power x into sin bx, that will be my nth order derivative. Okay. Now we have to modify. Okay, you have to modify something. We have to find out value of r and value of theta. What is my next target? My next target is to find value of r and value of theta. That is very easy. That is very easy. You can easily find value of r and theta. See that my a was r cos theta, my b was r sin theta, right? From our previous page. My a was r cos theta, my b was r sin theta. So at first we are dividing them, b by a. So my b by a become r sin theta by r cos theta, giving you tan theta. So my b by a become tan theta. So my theta is what? My theta is tan inverse b by a. That is why see that it is written here. My theta is tan inverse b by a. Okay, tan inverse b by a. Okay, this is my theta. And how we can find r? See that this is my A equal to R cos theta. This is my B equal to R sin theta. Square them and add them. কি করছি square করে add করো। Square করলে কি হবে দেখো, this will be a square, this will be B square, এখানে square করলে দেখো R square cos square theta plus R square sin square theta। ওকে, কি করেছি square করে add করেছি। তো square করে add করে দেখো a square plus b square become this। R square के कॉमन नहीं now, this will be sin square theta plus cos square theta, and this gives you a square plus b square equal to R square. See that what we obtain is a square plus b square equal to R square. So from this we are getting my R is equal to a square plus b square to the power half. That is written here. My R become a square plus b square to the power half. So put all these values in this equation. Put the value of R here. What is my value of R? My value of R is a square plus b square. See that we are putting all this value here. R to the power n. At first we shall substitute R to the power n. My R is a square plus b square to the power half, then to the power n. That is my R. Then e to the power x remain as it is. Don't substitute a here. It remain as it is. Okay, it will remain as it is. You know, don't need to substitute a here. Then my sin bx plus n into, substitute the value of theta here. My theta become tan inverse b by a. Tan inverse b by a. So this is my final result, which is written here. A square plus b square to the power n by 2. See that this is my square plus b square to the power n by 2. This is my a to the power x. This is my sin bx plus n into tan inverse b by a. Tan inverse b by a. Okay, so this is my final answer of this question. It's a very important part, e to the power x into sin bx. This become my final formula. This is my final and ultimate formula. Okay, if y equal to this will be my nth order derivative of y. So now there's an example. Okay, there's an example on this question. Okay, it came in different universities. Okay, like Kalyani, North Bengal, Calcutta University, so many universities, Jadavpur University, Presidency University. The question is, if y is equal to this, what will be my nth order derivative of y? If y is equal to this, what will be my yn? How we can solve this question? See that. We can easily solve this question. First of all, compare this. We have to find out y equal to e to the power 2x into sin x. So basically, compare with e to the power x into sin bx. Okay? So if you compare this with this, see that my a will be 2, my b will be 1, as written here. My a equal to 2, my b equal to 1. So what will be my r? My r is a square plus b square to the power n by 2. Put a equal to 2 here. 2 square means 4. B equal to 1. 1 square means 1. So that will be my 5 to the power n by 2. That will be my 5 to the power n by 2. Now this can be written as 5 to the power half to the power n. And 5 to the power half means root 5 to the power n. So see that my r become root 5 to the power n. See that my r to the power n, this portion. Okay, this portion become root 5 to the power n. Clear? Then e to the power x, it will always remain as it is, always. And then my sin bx, what is my b? My b is 1. So sin bx, put b equal to 1. If we put b equal to 1, we have only x here. We are putting b equal to 1, 1 into x, plus n into tan inverse b by a, right? So tan inverse b by a. So tan inverse, what is my b? My b is 1. What is my a? My a is 2. So tan inverse b by a, that will be tan inverse half. See that, tan inverse half. So this become my answer. But one more thing, before solving this question, prove this result. You have to prove this result. Okay, if you directly write this, you will get 0 in exam. Note this. You have to prove this. After that, put the value of A here, put the value of B here, as I have done here. Then e to the power x remain as it is. My B is 1. So 1 into x giving you 1. Plus n into tan inverse. My B is 1. My B is 1. My A is 2. So this becomes tan inverse 1 by 2. Okay, so this is my answer of this question. It's a very important question because this question came in several universities, Presidency, Jadavpur, Calcutta University, Kalyani University, and so many more. So this is my answer of this question. Okay, so coming to the next question, there is an example. This question came in Calcutta University question paper for major students. Okay, so this is an example. I again repeat, if you have more doubt on this part, don't forget to comment on description box. Okay, I shall clear your doubt. So my question is y equal to a to the power x sin x into cos 2x. Okay, so how we can solve this question? See that we can easily solve this question by using trigonometry formula. So see that e to the power x remain as it is, multiply by 2. We are multiplying by 2. We are dividing by 2. Why we are doing this? We are multiplying by 2. We are dividing by 2. Why? Because see that this will be my formula for 2 sin A cos B. 2 sin A cos B. Okay. So I again repeat, I shall upload a chart, formula chart on trigonometry in my description box that will help you to solve this question like this. Okay. So a to the power x by 2 remain as it is. So this is my formula of 2 sin A cos B. What is the formula? The formula is sin A plus B plus of sin A minus B. This is my formula. Okay. Sin A plus B plus sin A minus B. So after doing this, see that this becomes sin 3x and this becomes sin of minus x. And as we know, there's a result. Sin of minus x will be minus of sin x. Okay. So this become half multiply with e to the power x. Multiply with e to the power x. Sin of minus x, that will be minus of sin x. Okay. Sin of minus x, that will be minus of sin x. So my y become this. See that as written here, my y become this. Okay. This is my y. Then how we can find this derivative? So this is my y. So my what is my nth order derivative? My nth order derivative will be half of, as we know the notation. Okay, I have introduced this notation in my all the lectures in successive derivative. Okay, I have introduced this notation in all my lectures on successive derivative. So go through it at first. Then you can understand what is the meaning of this notation. So this is d to the power n means we are differentiating this n times. We are differentiating this n times. Similarly, we need to differentiate this n times. Basically, what we are doing? We are n time differentiating it, and then n time differentiating it. That is my nth order derivative as written here. So my d to the power n of this minus d to the power n of this. D to the power n means simply n time derivative. So these are my n time derivative. Go through it. Okay. Then what? Now see that we, okay, at first we need to find what? Now see that at first we need to find nth order derivative of this. Nth order derivative of this. D to the power n of e to the power x sin 3x. For this, we shall use my formula for nth order derivative of this. We shall use the formula. My formula was a square plus b square to the power n by 2 e to the power x, then sine bx plus n tan inverse b by a. We know this is my formula for nth order derivative. So if we compare, what is my a? E to the power ax. See that, e to the power ax. So my a is 1. Compare this with e to the power ax into sine bx. My a is 1, my b is 3. Okay? See that my a is 1, my b is 3. So write down here, my nth order derivative become my a is 1, my b is 3. Then e to the power ax remain as it is, sine bx. What is my b? My b is 3. So that is my 3x. Then n times tan inverse b by a. My b is 3, my a is 1. Say that it is given here. Okay, this is my 10 to the power n by 2, a to the power x sine 3x plus n tan inverse 3. It's a simple formula. Okay, this is my formula. We know this. Okay, we have already done an example. So this is my nth order derivative of this part, a to the power x into sine 3x. If you understand this, you can easily find nth order derivative of this, nth order derivative of a to the power x into sine x. See that if you compare this with my standard result of e to the power x into sine bx, my a will be 1. Here my a will be 1, my b will be 1. See that here my both a and b are 1. So my formula will be a square plus b square, 1 square plus 1 square. To the power n by 2, e to the power x, sine bx plus n into tan inverse b by a. This will be sine, my b is 1, then tan inverse b by a mane 1 by 1. 1 by 1 mane 1. So this will give you 1 square plus 1 square is 2. 2 to the power n by 2, a to the power x, sine, my b is 1. So 1 into x, see that my b is 1. So 1 into x is x. And we know what is tan inverse 1. How to find tan inverse 1? See that 1 can be written as tan pi by 4. This is a standard result. So tan inverse tan pi by 4 giving you simply pi by 4. So see that this tan inverse 1 become pi by 4. So this is my nth order derivative of e to the power x into sine x. Okay. So we obtain both these derivatives. Now we shall put in my equation 1 as given in my previous page. If we put them in equation 1, okay, what will be my y? See that if we put them, see that in my previous page, that was my nth order derivative. We substitute their respective values. E to the, see that half of nth order derivative of this minus nth order derivative of this. Okay, we have obtained nth order derivative of this. We have obtained nth order derivative of this. Then what? Now we are putting them here. See that we are putting them here. So what we are getting? Half of this, half remain as it is. This is my nth order derivative of this. This is my nth order derivative of this. We substitute them. So this is my final answer of this question. And if you understand this solution, try to find nth order derivative of this e to the power x into cos bx as we have done previously. Totally same approach e kintu solve hobe. যদি ওটা বুঝে থাকো এটাকে সলভ করো, সলভ করে আমাকে জানাও, যদি ডাউট হয় আমি সলভ করিয়ে দেবো। বাট আগে নিজে একটুখানি সলভ করো, নিজে যখন সলভ করবে না পারলে কিচ্ছু যায় আসে না, বাট ট্রাই তো করো, অ্যাটলিস্ট ট্রাই করো না। যতটা তুমি ট্রাই করবে তুমি ততটাই শিখবে, আর যতটা তুমি মনে করবে কপি করবে তুমি কিচ্ছু শিখবে না। ওকে, তো ইউ হ্যাভ টু আন্ডারস্ট্যান্ড দ্য কনসেপ্ট, হাউ উই ক্যান ডু দিস। Simply try to solve yourself. Don't copy from some book or from anywhere. Okay, so at first try to solve this yourself. If you are unable to solve, then I shall show you. So this is everything from this video. So I hope all of you have understood this solution. And still, if you have doubt, don't hesitate to comment in description box. Okay, so again, we shall meet in next video. Till then, bye bye.